Hello, everyone. Welcome to Science Division Live, Digital Earth Creating the Future. We have a very cool program for you today. While you're watching, if you have any questions, just type those into the comments and we'll keep an eye on those. And with no further ado, I'd like to introduce Dr. Kachun Yu, our curator of space sciences.
All right, thanks a lot, Mitch. I'm Kachun Yu, as Mitch says, and I'm an astronomer here at the Denver Museum of Nature and Science. And today I will be joined by my colleague, Dr. Bob Reynolds, who is a geologist and a research associate at the museum. And for today, for Earth Day, our topic will actually come in three parts. And what I want to cover is what makes planets habitable in our solar system and perhaps elsewhere. And then we'll focus on the Earth. What happens if we mess with those parameters of habitability? And then finally, what can we do to change our environment so that we can ensure a just and healthy future for everyone on this planet? And so with that, I'm going to switch us over to another view, which is for open space software. And what we're seeing now is our solar system, and you can see the orbits of the outer planets, Neptune and Uranus fading out of view, and then we're flying in towards the orbits of Saturn and Jupiter. These are all the gas giants. And as we close into the inner planets, now we're looking at the what we call the terrestrial rocky planets. So you have the red orbit of Mars, the blue orbit of Earth, the water planet, and finally the inner worlds, Venus and Mercury. And when we look at these outer or these inner planets, we are actually seeing what astronomers call the habitable zone. And this is another name for it is the Goldilocks Zone. And that's just because you're looking at this regime where in some places, some distances from the sun, it's too hot for liquid water to exist on the surfaces of these planets. In other places, it's too cold. And then right in the middle, where the Earth orbits, it's just right. And so we'll be talking briefly about what makes planets habitable. And clearly, Venus is one of those worlds that are at the limits. Well, it's definitely not habitable for Earth-like life because it's much too hot. It has a thick carbon dioxide atmosphere that makes its surface much hotter than what you can get in your home oven. And the planet that's at the edge of the habitable zone is Mars, and we'll fly down to it. And people have long talked about Mars as being sort of not quite the twin of the Earth, but the place in the solar system that's closest to potential habitability. And as we fly in, we'll come up on the cold, dusty world of Mars. And as we saw, Mars is at the limit of habitability. It's located about 50% further from the sun than the Earth. And as we fly in, we see a cold desert world. We think that Mars was warmer, had a deep, thicker atmosphere far in the past. But today, much of that atmosphere has been lost into space just because Mars doesn't have a magnetic field like the Earth. And as a result, the solar wind and cosmic rays has stripped much of Mars's atmosphere away, and Mars has also lost most of its water. The other feature on Mars is that because of its thin atmosphere, it isn't protected from meteor and asteroid impacts as much. And so as we zoom down to the surface, we're actually zooming down to a crater, Jezero crater, which is where the Perseverance rover landed a couple months back. And we're actually coming down straight to the spot where it landed. You can see on the upper left is actually sort of like a river feature, a channel that comes and then it comes out into a river delta feature. And so deltas form when fast flowing water runs into a lake or a sea, and the water slows down, and all the sediment in the water precipitates out, and it forms that delta. And so we think that billions of years ago in the past, when Mars was warmer and wetter, there was flowing water. We see evidence of that from space that we're seeing now. And the Perseverance rover is designed to hunt for and to find potential evidence of past life on Mars. But as we see, even though conditions on Mars were much better in the past, today it's a very desolate world. And so even though there are, we are interested in sending astronauts to Mars, perhaps another 10 or 20 years, and there are even people here on Earth who are interested in living on Mars and colonizing the planet. This is an extremely difficult thing to do, and that's just because you would have to provide everything that you need to survive on Mars, including air and water. And there's also quite a bit of evidence that the soil on Mars is poisonous. So even though Matt Damon was able to grow potatoes on Mars in the movie The Martian, a truer picture would probably be a lot bleaker given the conditions that we know of about the Martian surface. So with that, I'm going to turn us towards our home planet, planet Earth. And as we close in on our home world, we see a beautiful blue marble floating in space. This is our spaceship Earth. And as we fly in, we see the white of the clouds and the blue of the oceans, evidence that liquid water exists on the surface of the Earth, as well as in its atmosphere. And it's water that makes life as we know it possible. And so with that, as we fly down towards the Earth, I want to turn it over to my colleague, Bob.
Great. Thank you very much, Kachun. And I'm Bob Reynolds. I'm a geologist and I'm a research associate at the Denver Museum. And over the past few years, we've been putting together programming on what the Earth looks like from space. And we call them Digital Earth programs. And we're also doing a Digital Earth Academy program now for students. So those of you who are students can join us for Digital Earth Academy, and museum members are always welcome to come to our Digital Earth programming. What we're going to do now is we're going to look at the Earth from above, and we're looking at North America, and you can see the colors are variable. There's green colors on the eastern side and sort of yellowish and gray colors on the western side. And this really has to do with the large-scale distribution of water and water resources. And Kachun's mentioned that water is one of the critical ingredients for life. And here in the western part of the United States, we are facing water challenges. And you can see from space that the western part of the United States and parts of Mexico are very bright colored. They're light grays and almost whites in some places. And those are the very reflective desert surfaces where there's almost no vegetation cover. And we'll zoom in a little bit more closely and we'll start to recognize the Rocky Mountains. You'll see Baja California at the bottom. You'll see California on the left-hand side. And you're seeing all of Nevada with the Basin and Range in the middle, and then the Colorado Plateau, as we call it, which is western Colorado and much of Utah. And the Rocky Mountains themselves are covered by forests, but the ground below the Rockies and coming down into the Colorado River drainage, going down through Utah and into Arizona and Nevada, it's pretty dry, and there's not a lot of vegetation, so you get these relatively bright colors. And we're going to be looking more closely at this territory here. This is the Colorado River is running right through the center part of the screen here. And I think you'll start to pick out some reservoirs on the Colorado River. Lake Powell is in the upper right, and Lake Mead is sort of in the middle central part on the left-hand side a little bit. And the Grand Canyon is the wonderful feature that you see on the right-hand side of the screen right there. So the Colorado River flows through the Grand Canyon, and then the Hoover Dam holds it up, and you're seeing the reservoir, man-made reservoir, and the city of Las Vegas. And I guess we've got a time-lapse photograph series put together from Google Earth, and you can see this is about a 32-year cycle starting in 1984, and we'll run it several times. It runs from 1984 up to 2016. And if you look closely at this moving image that's cycled back here, it's starting in 84, and you'll see the city of Las Vegas growing. And the footprint of that city, which you can see a grid of roads and the gray patterns representing urbanization, it's growing across the desert until we get here to 2016. Then we start over again. And you can see the size of Las Vegas has almost doubled, at least in terms of its footprint in that time frame. On the right-hand side of the screen, you can watch Lake Mead. Lake Mead, again, held up by the Hoover Dam. And if you look closely at Lake Mead, through this cycle, you will see it is shrinking. And that is one of the situations we're facing now in the arid southwestern United States. These big reservoirs are shrinking. There's bathtub rings around them. If you go to Lake Mead today, you'll see a big bathtub ring around it. And in fact, it holds about half of the water that it once held. So the water volume in Lake Mead is down to almost 1/2. And the people here, you can see Kachun zoomed in, and you can actually see the white stripe around the margins of the lake. And that's the part of the lake shore that has been exposed by the falling lake levels. The city of Las Vegas gets the vast majority of its water resources from Lake Mead, from the Colorado River. And they've had to dig an extra tunnel into the lower part of the lake in order to be able to assure themselves that they can get the last drop of water out of Lake Mead. And the challenge that we're facing here throughout the southwestern US as we back up and look again at this somewhat arid landscape, the conditions today are dry and getting drier. And with climate change as it gets warmer, this is a current version of the Drought Monitor Map. This is available on the internet, and you can pick it up once a week. They update it on Thursdays. And this is the version from last week, April 15th. And the dark color there is exceptional drought, and the reddish color is extreme drought. And you can see, if you look closely, you'll see the trace of the Colorado River, which comes in, of course, from Rocky Mountain National Park in Colorado. And it's joined by the Green River that's coming out of Wyoming. They come together just south of Moab, and they flow together through Lake Powell and Lake Mead, heading down towards the Gulf of California. And as it gets warmer, there's increased evaporation and increased evapotranspiration from the plants, and there's less and less moisture available to flow into the river systems. And the southwestern United States is dry, and we think in a long-term phase of getting drier, or what we call aridification. The cities of Las Vegas, Tucson, Phoenix, and parts of Southern California are right now in active negotiations trying to figure out what they're going to do, how they're going to share water resources from the Colorado River as it dwindles. We're going to look at one other significant example of change going on the face of the earth that we can see from space. We're going to move across North America, across northeastern Canada, Labrador, and we're looking at Greenland. And Greenland, of course, is capped by ice, very thick layer of ice, in places thousands of meters thick. And the ice is flowing through a series of glaciers into the North Atlantic and making icebergs, like the iceberg that sunk the Titanic many years ago. And these glaciers are flowing faster and faster, carrying melting water and ice into the North Atlantic from the Greenland ice cap. And the Greenland ice cap is losing mass. Every year it gets a little bit smaller. And there have been lots of studies of these glaciers that are feeding into the sea here. And the glaciers are retreating as they melt, and they're also accelerating. They even create little earthquakes. There's ice quakes associated with the movement of the ice against the bedrock in Greenland. You can detect it using seismometers. The Greenland ice mass itself contains a huge amount of water locked up in ice. If it were to entirely melt, it would raise sea level significantly, 7 meters. Here you can see the ice sheet loss of weight or mass loss through time from 2002 to 2020. And this is data obtained from satellites monitoring the gravitational pull of Greenland. It's a very wonderful, refined system. They're called the GRACE satellites, and they are 2 satellites flying in tandem, side by side. And as they approach something that's very heavy, the first satellite will accelerate a little bit and the second satellite will lag behind. If they are over territory that's relatively light or low mass, the first satellite will slow down a little bit. And they measure the distance between the satellites down to the micrometer or micrometer, and they use it as a way of looking at change of mass through time. And here you can see that trillions of metric tons of ice are being lost from the Greenland ice cap. And you see it slows down in the winter and speeds up in the summer. So there's sort of a cyclical pattern there. But this is a clear manifestation of the fact that it's getting warmer and Greenland is losing its ice. Now, the ice in Greenland flows directly into the sea. As you know, you can see the meltwater there on the image just behind us. And those are melt ponds on the surface of Greenland. And occasionally they develop fissures, and the water drains out of those melt ponds, goes down to the bottom of the ice mass. And we actually think that the water flowing down from the surface of the ice into the depths of the ice mass helps to lubricate the glaciers as they're flowing across the rock. So there's a feedback there. As you get more water into the glacial system, it accelerates the flow of the glaciers as a positive feedback. Now, coming back to the results of the melting water flowing into the ocean, here we've got a sea level graph. And this again is data that goes back to the 1800s. And we've had a tremendous variety of technologies for measuring sea level. It's a tricky business. We do it with tide gauges, of course, and marks on the coastlines. And the coastlines are complicated around the world. Some coastlines are subsiding. Other coastlines are actually rising because of tectonic forces. And so if you're measuring sea level from a measuring stick on the edge of a continent, you've got to be aware of the combined effects of sea level change and the change of your land mass. And this makes it very complicated. But over the years, we've gotten many different measurements across the world by hand. And then starting in the 1970s, we've switched over to a data series that is coming from satellite radar altimetry measurements. And sea level is actually being measured from orbiting satellites. And they're taking thousands and thousands, hundreds of thousands, millions of measurements, averaging them together and coming up with the graph that you see in the dark color on this curve in front of us. And you'll see that there's a gradual change in sea level. It is rising, and its rate of change is increasing a little bit as we go forward in time. And today, sea level is rising about 3 millimeters per year. And you might say, well, that's the thickness of a coin or something. It's not very much. But as a geologist and as somebody who studies, processes and patterns on the Earth's surface, that 3 millimeters a year adds up. And if it were to accelerate, which it might do, it's going to cause significant change around the coastal areas of the world. So we've mentioned a couple of issues here. We've talked about aridification, where things are getting drier, and that's common in many of the drier parts of the world. We've talked about temperatures going up and causing melting and causing ice to melt and go into the oceans, rising sea level. And it's now, we're going to come to the third part of our presentation, and we'd like to take Earth Day as an opportunity to look at the Earth from above, recognizing that it's a beautiful planet. It's the only planet we've got. There's 7.7 billion people, passengers, if you will, riding on this planet. And we are collectively, all of us, challenged to figure out how to live sustainably on this planet. And we're looking now at North Africa. You'll see the Mediterranean at the top, Spain just going out of view, and Lake Chad is right smack in the middle. And again, the color here reflects the fact that the central part of Africa is green and it rains in that area. The northern part of Africa is the Sahara Desert. It's relatively dry, in some cases extremely dry. And the moisture is so limited that there's almost no vegetation across much of the Sahara, as you probably know. And this has caused, of course, a huge challenge for people as it gets drier in some of these areas. It's challenging to live in the zone between the Sahara Desert and the green ground to the south. That area is called the Sahel. That's the name of that geographic region. And the Sahel is an area where the desert interface is a challenge for the people. It's arid to the north, a little bit less arid to the south. Rainfall is intermittent. And in this area, there is a program that's been going on for 6 or 8 years, coordinated by 10 to 15 countries to create a vegetation strip, and they call it the Great Green Wall. And it's not going to be a single wall, but it is going to be a zone where they're trying to revegetate, plant trees, and essentially hold the desert back. And as Kachun brings us in here, we've got Lake Chad going off to the northeast or the upper right of your screen, and we're coming into the country of Niger. We're down on the southwestern part of the Sahara Desert, and you'll start to recognize patterns of areas that are being experimentally revegetated. And some of these are nature preserves, and some of them are actually planted forests, but you'll recognize a variety of shapes here that are somewhat darker. And these are zones where people are on the ground trying to allow the trees to grow, allow vegetation to recover. And it's a very tricky business. Here's what the landscape looks like. And it's an area where nomadic people live. There are small settlements, but many of the people in this area make their livelihood by herding goats and sheep and camels. And so you've got to, if you're planting trees or trying to grow vegetation, you've got to negotiate with your colleagues and your countrymen who are trying to herd the animals. So the people living in these landscapes are trying to adapt and develop new systems where they can keep some of the vegetation growing and still have enough fodder for their grazing animals. A big challenge in this part of the world. But as you can see from space, they're being successful. And the hope is that these green areas will start to link up, and that eventually there will be essentially a wall of vegetation separating the Sahara Desert from the greener parts of Central and Southern Africa. We're going to back up a little bit now and move over a little bit to the east, and we're going to find a wonderful river flowing in the desert. Many of you might guess the name of a river flowing in the desert, and we're coming up on the Nile River. And we're just going to quickly see the same thing. We're going to look again at irrigation systems and vegetation patterns. And we're coming in onto the Nile River near the city of Aswan, near the Valley of the Kings. Some of you might have been there, Valley of the Queens. Beautiful, beautiful areas. And as we look at the Nile River, you can see it's very well defined by the green band, of course, of irrigated land adjacent to the blue waters of the Nile. But if you look more closely, and Kachun's going to zoom us down in to an area where you can see the edge of the Nile irrigation. And if you look closely, you'll see that the Egyptian people are expanding into the desert areas adjacent to the Nile River, and they're going into unconventional areas using new technologies for irrigation. And we visited this location a few years ago and talked to some of the farmers, and they're using wells where they're drilling for groundwater, and then they're using drip systems to efficiently irrigate the desert. And these are areas that are beyond the reaches of the canals from the Nile River, and they're using new technology to make agriculture possible in areas where it never used to be possible at all. So this is one of the ways in which technology is being used to use limited water supplies to help grow increased food supply. And you'll see a variety of techniques here. There's some center pivot irrigation systems there on the right, those circles, and then a variety of other little irrigated patches. And again, the farmers in this area are very entrepreneurial. They're very technologically savvy, and they're making very efficient use of the limited water resources of Egypt. And we're going to see another example of that in just a minute as we back out. We're going to cross away from Egypt, and we're going to cross the Gulf of Suez, the Suez Canal that was in the news recently, the Sinai Peninsula, the Gulf of Aqaba, and we're going to cross into Saudi Arabia, a little bit further to the right, coming in, and we'll see this patch of vegetation in the middle of the desert in Saudi Arabia. And as we get in close, you'll see a dramatic geometric pattern here. And these are center pivot irrigation systems, a lot like we use here in Colorado. And they've tapped into groundwater that's underneath the desert floor, and they're growing crops in the desert using very efficient irrigation systems using center pivot. And it's a constant challenge to figure out how to balance the groundwater resources, because they are finite. And the people in Saudi Arabia are learning how to optimize their use of groundwater. They're also experimenting with desalinating water in Saudi Arabia, where they have abundant energy, and they're experimenting with desalinating seawater in order to grow crops as well. We're going to scoot back out, and we're just going to look at a couple more places before we finish up. We're going to leave the Saudi Arabia, but we're going to stay in the Arabian Peninsula area. There's the Persian Gulf. Iraq is on the left, Iran on the top. And we're coming down into the United Arab Emirates on the southeastern side of the Persian Gulf. And as we zoom down in here, this is we're coming into the Emirate of Dubai. And it's an extremely amazing place where they're creating fantastic new cities in the desert. And some of these cities involve building out into the Persian Gulf itself. And of course, sea level is rising in this area, as it is everywhere around the world, but they're protecting the construction projects with massive seawalls. They're accommodating the fact that, recognizing the fact that sea level will be rising, and they're building these man-made islands. This is called the Palm Island. They're building these islands out into the Persian Gulf, and you can buy an apartment out here with a wonderful view of the ocean. And it's an amazing example of geoengineering that's clearly visible from space. He's showing us where you park your boat. So there's the yacht parking lot there, and some of the big apartment buildings that are located in this Palm Island. It's a beautiful example of technology being used in a very innovative way to make, this is a very arid zone, but make the arid zone habitable. And you put in a swimming pool, and you can have a very nice life. And they say that they're within 5 hours flight of half the world's population at the Dubai airport, and it's become the busiest airport in the world. So fantastic growth and a fantastic tribute to engineering. And we're going to make one last stop before we end. And we're going to allow some time for questions and answers at the end. If those of you who wish to stay along, our program will be about half an hour long. We're going to end at 12:30. But if you want to stay, we can have some Q&A. But we're coming into China now, and we're going to be looking at some land just to the west of Beijing, on the eastern edge of the deserts here, which include the Taklamakan Desert, which is just going out of view, the Tarim Basin, and the Gobi Desert. Very arid areas. Again, you can see the brighter colors associated with the relatively dry ground. And the people in China are making a huge effort to stabilize the desert so that it doesn't blow as much sand into the cities, where they have a big problem with dust and air pollution. They're also putting in very large solar panel facilities to generate electricity. And the Chinese people are amongst the biggest country in the world in terms of solar energy production. And they've got many huge solar facilities, photovoltaic systems set up out in the desert areas in central and western China. We're going to take you to one of those, and it's a little bit of tricky business, but there's a very interesting pattern that I'm going to ask you to look for as the finale here for our Earth Day show. We're coming down and we're looking at photovoltaic panels in China, just west of Beijing. And I'm going to ask you to look for the photovoltaics. They're a little bit hard to see. There's some irrigated ground here, but there's some big gray patches that will turn out to be solar panels. As we get in close enough, we'll have the computer system will catch up, and you'll get some higher resolution. And we're looking for a particular pattern of photovoltaics, which is a little bit difficult to find. And Katrina and I have been here quite a few times looking at this, and it's hard to get good landmarks, but I'm asking you to look for a pattern. And I'll give you a clue as we get a little bit closer, but we're looking for photovoltaics that have a pattern, and they are curiously hard to find.
Yeah, we found it before the other night, but
I think it's at the
I've
upper
gotten lost here.
No, I think upper. No, you're close. You're very close. Back out a teensy scotch, because I'm looking for that lake-like thing. There, I think it's right near you.
Yeah, I see it now.
Yeah. So we're
It's just
coming
too far west.
Yeah, the gray features in here are the photovoltaic panels, and they're in big fields, big areas of them. And so there's giant, and there's a little bit of a pattern. You can see some little white dots in them. But now, Kachun's bring us in. You should see something. Does anybody see something? I'm looking in the chat. I'm listening to see if you see anything. These are photovoltaic panels set up in the pattern of a characteristic Chinese favorite animal. And I think I'm hearing through the ether that people are seeing and recognizing panda bears. And in fact, these are the panda photovoltaics in China. So this is, again, an illustration of how relatively arid land is being used to generate electricity, as well as, of course, there's some wonderful irrigation projects in China, and they're planting trees and holding the desert back in China as well. So we're going to end with the thought that we all are riding on this planet in space. It's in the habitable zone, but it's the only planet that we've got. And it's the only planet that we know of that has the right conditions for life. And there's 7.7 billion people riding together on the planet. And we need to work together. We need to collaborate. We need to share solutions. And we can, and we are. And there's lots of examples of that. So here you're seeing photovoltaic panels. You're seeing high efficiency irrigation. We can talk about other examples where global communication has helped technology, people working around the world, creating medicines, creating vaccines, global collaboration, allowing us to do wonderful things, because amongst those 7.7 billion people, there's lots of eager hands, and they're all eager to help make the earth a better place. So thank you all very much for attending, and we will be available for some questions and answers if anybody has any further that you'd like to discuss. Thank you again, and thank you from all of our museum staff behind the scenes here that have been helping out to make this work. Tim and Mitch have kept this process going. Thank you.
Well, wonderful. That was wonderful. We didn't get any questions yet, just a few compliments. Some Digital Earth fans saying this is amazing and they miss being in the planetarium. But it's great that we can still bring the program out. And if you are a Digital Earth fan, there are several archived videos on our YouTube channel. If you'd like to see Bob and Kachun take you all over the world and explore a variety of different topics. So yeah. If anyone does have a question, you can pop that in. We'll be live for a few more minutes.
Yeah, well, thank you, Mitch. I'll just mention one last thing just to underline, I think the value of science and science education, we've chatted a lot about that at the museum. And these programs, Digital Earth and Digital Earth Academy, are really designed to help people get to know their planet a little bit better, if you will, global geography. And if we know the planet better, we can take care of it better. So the Denver Museum is eager to invite you to come to the museum. We are open, and it's timed entry. You've got to get a ticket ahead of time, but come to the museum. We've got wonderful displays, and we're building new displays all the time. So we hope to see you live at the museum soon.
Well said. And as the Earth retreats in the background, I think that's a good time for us to say Happy Earth Day, everyone, and thanks for joining us.
Thank you, everybody.
Thanks, everyone.